Okay, in this video, I'm gonna show you how to determine the coefficient of each term after when we expand this expression a plus b raised to the power of m. And we're gonna use the Pascal's triangle to help us. So this is an example of Pascal's triangle. It's a part of the triangle. In the first row, there are two numbers, 1 and 1. In the second row, there are three numbers, 1, 2, 3. In the third row, there are four numbers. And the pattern is in each row, the first and the last numbers are always 1. You see, the first number and the last number are 1. And here the first number and the last number are 1. Okay, the first number and the last number are 1. And for the numbers between them, each number is a sum of the two numbers above it. For example, 3 is a sum of 1 and 2. See, 3 is a sum of 2 and 1. And here 2 is a sum of 1 and 1. So 4 is a sum of 1 and 3. 6 is a sum of 3 and 3. 4 is a sum of 3 and 1. So therefore, if I want to write the next row, so I know there should be 6 numbers, and the first number and the last number are 1. So the second number is a sum of 1 and 4, which is 5. And the third number is a sum of 4 and 6, so it's 10. And the fourth number is a sum of 6 and 4, so it's also 10. And the fifth number is 5. Okay? And using this way, you can continue to write whatever the row. Okay? Now I want to talk about what's the relationship between the Pascal's triangle and this integer m. So the first row corresponds to when n equals 1. The second row corresponds to n equals 2. So this is n equals 3, this is n equals 4. Now, the numbers gonna tell us how many terms in the polynomial when we expand a plus b raised to the power of m. So when n equals 1, since there are two numbers, so there are only 2 terms, right? And when n equals 2, in the second row there are 3 numbers, so we should have 3 terms. Okay, 3 terms. And each number corresponds to the coefficient of each term. So the first term, the coefficient is 1. The second term, the coefficient is 2. The third term, the coefficient is 1. So that's why a plus b raised to the power of 2 is 1 times a squared plus 2 times a times b plus 1 times b squared. See, the coefficients are 1, 2, and 1. Now, if I wanna find out what is a plus b raised to the power of 3, so I should look at the third row, and the numbers are 1, 3, 3, 1. Therefore, the coefficients are 1, 3, 3, 1. So the result is a to the third times b to the power of 0 plus 3 times a squared times b, and plus 3 times a times b squared plus a to the 0 times b to the third. And if we write a b to the 0 and a to the 0 back to 1, so the result is this. Okay. Now let me do another example. Let's see. I want to find what is a plus b to the power of 6. Okay. So because right now n equals 6, I need to determine the numbers in the 6th row. So this is the 5th row. So now in the next row, this is 1, and the last number is 1. So this is 6, 1 plus 5. This is 15. This is 20. And this is 15. This is 6. Okay. So let me write it here. So the numbers are 1, 6, 15, 20, 15, 6, 1. Remember, these numbers are the coefficients of each term. And there should be 7 terms. So the first term is a to the power of 6, b to the 0, plus a to the power of 5, b to the power of 1, plus a to the power of 4, b to the power of 2, plus a to the power of 3, b to the power of 3, and plus a to the power of 2, b to the power of 4, plus a to the power of 1, b to the power of 5, plus a to the power of 0, b to the power of 6. Okay? Remember, the order of the exponent of a is 6, 5, 4, 3, 2, 1, 0, and the order of the exponent of b is 0, 1, 2, 3, 4, 5, 6. Okay, and then we add the coefficient. So this is 1, this is 6, this is 15, this is 20, this is 15, this is 6, this is 1. And then we are done. Now, do you get this method?